So as I'm recording this, my son is halfway through college, which is pretty cool as a father. But at the same time, it also means that from here on out, for the rest of my life, most or all of my students will be younger than my son. Shit. I remember when I took him to his freshman orientation a couple years ago. There was about a few hundred of us in this one big room. And I remember sitting next to us with another family. It was mom, the son, and the dad. And the mom was right next to me. So I remember, like, with 5 or 10 minutes left to go, out of the corner of my eye, I just kept seeing mom writing furiously in this notepad and making this list, talking seriously to her son. And I wasn't sure what she was doing because nobody was up there saying anything. I had no idea what she was writing down. And finally my curiosity got the better of me and I had to peek over at what she was doing. And she was writing this list of notes to her child because apparently she had no faith in the 2 days of orientation that was coming. And the only one that I really remember, for reasons that will soon become obvious, was the one at the very top. I had her number 1 on her last gift to her son before he goes off to college. My first thing she wanted to tell him was that chemistry and math are hard for you. Yeah, really, what are the odds? And needless to say, it did rub me the wrong way a little bit, because it wasn't science and math, it wasn't chemistry and calculus. She singled out my thing. Wow, thanks for that, lady. I'm not going to be the one to teach him chemistry. I teach somewhere else, but whoever ends up teaching him, you've just made it that much tougher for him. Thanks. All that aside, what kind of parent makes that kind of list for their son before they go off to what should be the best 4 years of their life? Or 5 or 6. Seriously, you psycho mom, what is wrong with you? In my head, I said this. I'm not going to just go off on some parent right before freshman orientation starts. Especially one that had all the markings of what I like to call Mama Grizzly syndrome. Because I see it a lot. At the college I work at, a lot of times we're asked to help with advising, especially right before the semester starts. And I'm not saying this is always a mom and her son. And sometimes it's a dad and her daughter. But most of the time, when I see stuff like this, it's a son and a mom who just cannot let their child out of the nest with grace. And you try looking at the kid, you try talking to the kid, you try asking him questions, but just out of the side, off to the side, you just keep hearing Mama Grizzly. I don't think you should do a lot of hard classes. Like maybe save the math and science for later. Like maybe start with some easy stuff like, art or humanities class. Because I've done some research online about this and they say that, the child should really take a few easy classes to start with, just to kind of ease him into things. Oh my God, will you give this child some space to breathe for once in his life? Again, to myself, I say this. I'm not going to say this to Mama Grizzly. Because if you give any kind of impression to Mama Grizzly that she might have made one little misstep with her darling little son, she will scoop her little boy cub up and just... So today we're going to do a little bit of stoichiometry, which is the point in the course for General 1 where I like to say the fun begins, /S. Because this is the point where things can really start to catch up to you if you haven't really been keeping up as well as you should. And for my class, it usually comes right after the first exam. We start to get into the reactions and reaction math after exam 1. And if you kind of skated by exam 1, this is when things start to catch up to you. So if you're struggling with stoichiometry, before watching this video, or if you just want to try to watch it but it's still not helping, I would say go back and watch or read or do whatever. Read some stuff dealing with dimensional analysis from chapter 1. Or maybe look into the gram to mole conversions that you were probably taught right before you got into reactions and stoichiometry. Because again, a lot of that stuff leads into stoichiometry. So the idea behind stoichiometry is if you think of a chemical equation as being kind of a recipe for making a given product or products, stoichiometry is essentially scaling that recipe to meet your needs. Kind of like how in a kitchen you would scale a recipe up or down to meet whatever needs you need. Let's say a recipe serves 4. If you need to serve 8, you double the ingredients. If you need to serve 2, you cut the ingredients in half. But with a chemical reaction, it's not always scaling in the sense of doubling or cutting things in half, which is why it's usually best to kind of approach it as a conversion problem, like some of the dimensional analysis stuff we talked about in chapter 1. But before I do any type of chemical reaction examples, I like to start with a kitchen example. And my sort of go-to example is usually a burger, such as the Hardee's Monster Burger. Now, this video isn't sponsored by Hardee's, but yeah, I wouldn't say no, Hardee's. If you're listening. No? All right. So if you look at the sort of basic ingredients for this monster burger, you've got a couple of patties. You've got a couple of slices of bread. You've got 3 pieces of cheese. And we'll call it 4 slices of bacon. That plus some other condiments we won't bother putting up here gives you 1 burger. Now let's say you've got 12 slices of bacon. How many slices of cheese would you need if you wanted to use all that bacon up? So if you approach it like a dimensional analysis problem, you're trying to convert slices of bacon to slices of cheese. And if you look at our recipe here, it looks like for every 3 slices of cheese, we need 4 slices of bacon. So if we use that as our conversion factor here and set it up where the unwanted bacon unit drops out, that will give us 9 slices of cheese. Compare that example to one using an actual chemical reaction, like the one between aluminum and oxygen to give you aluminum oxide. One way to read this equation is you have 4 atoms of aluminum reacting with 3 molecules of oxygen, and that will give you 2 molecules of aluminum oxide. And I'm putting molecules in quotes because aluminum oxide is technically an ionic compound, so it's not really a molecule. I know you don't have to email me. But let's say we want to react 12 atoms of aluminum. How many molecules of oxygen are we going to need? So again, we set it up like a dimensional analysis problem, a unit conversion problem. So we're going to start with our 12 atoms of aluminum. And according to our chemical equation, for every 3 molecules of oxygen, we're going to need 4 atoms of aluminum. Using that as our conversion factor, we set it up where the atoms of aluminum drop out, and that will give us 9 molecules of oxygen. But when you read a chemical equation, especially in a college level chemistry class, you really shouldn't think of those coefficients in terms of atoms and molecules. You should think of them in terms of moles. Think about it on the mole scale. 4 moles of aluminum reacts with 3 moles of oxygen to give you 2 moles of aluminum oxide. So let's say you want to react 50 moles of oxygen. I thought I'd use a different number this time. How many moles of aluminum are you going to need? So you just start with the unit we're given, moles of O2. And that 4-to-3 relationship that we saw in the previous example with atoms and molecules, that still holds true on the mole scale. It doesn't matter whether you're looking at things on the atomic scale or 4 dozen of one versus 3 dozen of the other, or on the mole scale. That 4-to-3 relationship between aluminum and oxygen in this reaction is going to be true. So if we think about it in terms of moles, just like we did last time, 4 moles of aluminum for every 3 moles of oxygen, the mole unit drops out, and that'll give us an answer in units of moles of aluminum. So in stoichiometry, whenever you want to do that mole-to-mole type of conversion, all you have to do is just look at the chemical equation that's given and think about those coefficients in terms of moles. And whatever those coefficients are, that's your conversion factor. So let's go back to our burger example and look at one more thing. In that example, we used the relationship that 3 slices of cheese needed 4 slices of bacon. But if we were working with 3 pounds of cheese, that wouldn't necessarily mean that we'd need 4 pounds of bacon. Because our recipe here between cheese and bacon, it's not a mass relationship, it's a numeric relationship. So, and cheese and bacon, they probably weigh different things. So let's say that in the case of cheese, about 20 slices equals a pound. And bacon, a pound is about 12 slices. How many pounds of cheese are you going to need for 3 pounds of bacon? So just like any conversion problem, we're going to start with the unit we're given, in this case, pounds of bacon. But to use that 3 to 4 relationship that we used before, we've got to convert pounds to slices. But we know how many slices we have per pound. So we can use that as a conversion factor to get us into slices of bacon. Now we can use our 3 to 4 relationship to get us from slices of bacon to slices of cheese, just like we did in our very first example. And since they're asking for pounds of cheese, well, we know how many slices per pound we have for cheese. We can use that to go from slices of cheese to pounds of cheese. And that will give us 1.34 pounds of cheese. Are you getting hungry yet? I sure am. So with chemical reactions, again, everything in our equation is usually thought about in terms of moles. But you can't count a mole of anything. It's just a mole is too big of a number. But you can weigh things on a balance. And we know the molar masses of elements, and we can figure out the molar masses of compounds. So going back to our aluminum oxygen example, we know that aluminum is 26.99 grams per mole. And we know that oxygen is 32 grams per mole. So let's say we're starting with 50 grams of oxygen. How many grams of aluminum are we going to need? So again, before we can use that 4 to 3 relationship, we need to convert grams to moles, because you think about the coefficients in terms of moles. But we can use molar mass to go from grams to moles. And once we're in moles, now we can go from moles of what's given to moles of what you want, just like we did in our mole to mole conversion earlier. And if you want an answer in grams, we can use aluminum's molar mass. Set it up where the mole unit drops out, and that will give you an answer in grams of aluminum. So one thing to notice as you're looking at this stuff at this point in the course is that these stoichiometry problems, the stoichiometry math, it's the same math that we did back in chapter 1. All those dimensional analysis types of conversions. We were doing those because we're going to be doing those a lot from this point forward, mainly in stoichiometry type stuff. And at this point in the course, we're only doing 2 types of conversions. We're doing a gram to mole conversion using molar masses, and we're doing these mole to mole type conversions using the coefficients in whatever chemical equation we're looking at. And that mole to mole conversion, that's the main stoichiometry conversion that we're going to do in pretty much any type of stoichiometry problem. Yeah. So, and it's a lot easier to remember that conversion if you think about the coefficients in terms of moles, kind of like I said before. And just whenever you want to convert moles of one thing to moles of something else, just look at the coefficients and think about them in terms of moles. But that'll be it for now. And we'll look at some other stuff later. Bye. Well, I hope you've had fun in college, Billy, but remember, chemistry's hard for you. Hey, before these orientation starts and all these people tell you that anything's possible, here's the list of things that you should be concerned about. I don't even know what was on the rest of the list. Chew your food slowly. Remember, bedtime at 9. If they're going to make you do stuff like that, they're not your real friends. The world is against you. Stay away from sorority girls.
She'll never love you like Mama does.